There is a quiet corner behind almost every independent automotive shop in North America where the past is stacked in cast iron. Engine blocks, mostly from vehicles built between the late 90s and the early 2020s, sit in uneven rows on wooden pallets, their cylinder bores open to the weather, oil pans removed, head bolts still threaded into the deck surfaces. Some are streaked orange with surface rust. Others are coated in a film of dried coolant that has turned the color of weak tea. To the casual observer, they look like industrial debris waiting for a scrap hauler. To a metallurgist, a hydrologist, or an environmental compliance officer, they represent something more complicated, a slow-motion logistical problem that the automotive industry has not been forced to solve, and that, in 2026, is finally beginning to attract the kind of attention it has avoided for nearly a century. The reason has to do with timing. The internal combustion engine is not disappearing overnight, but the curve of its retirement has steepened dramatically. According to data compiled by the Alliance for Automotive Innovation and corroborated by registration figures from several European transport ministries, the global fleet of light-duty gasoline vehicles peaked somewhere between 2023 and 2025 and is now declining for the first time since the post-war era. The vehicles themselves do not vanish. They are dismantled, exported, parted out, or crushed. And at the heart of each of them sits a block of cast iron or aluminum alloy weighing between 40 and 200 kilograms, designed to last longer than the car around it, and now, increasingly, surplus to the needs of any market that wants it. For most of the 20th century, this would not have been a problem. A scrap engine block was simply a dense, valuable piece of ferrous metal. It went to a shredder, was reduced to fist-sized fragments, separated magnetically from the non-ferrous material, and sold by the ton to electric arc furnaces that melted it back into rebar, structural beams, or new automotive castings. The loop was, if not perfectly closed, at least reliably circular. The economics worked because scrap steel commanded a steady price, because shredders were plentiful, and because the cast iron in an engine block, despite its high carbon content, blended acceptably into the broader steel feedstock. But that system was built around assumptions that no longer hold. Modern engine blocks are not what they were in 1985, and the infrastructure designed to recycle them has not kept pace with what they have become. The first complication is metallurgical. Beginning in the late 1990s and accelerating through the 2010s, automakers under pressure to reduce vehicle weight transitioned large portions of their engine production from gray cast iron to aluminum silicon alloys, and in some cases to compacted graphite iron.
Agreed.
A material engineered to be lighter and stronger than traditional cast iron, but considerably more difficult to recycle. A modern aluminum block from a turbocharged four-cylinder engine may contain between 7 and 12% silicon, along with smaller quantities of copper, magnesium, manganese, and trace amounts of strontium or sodium added as modifiers. When such a block is fed into a conventional aluminum recycling stream, its composition is too contaminated for use in high-grade applications such as body panels or structural castings. It can be downcycled into engine blocks again,
Australia has a later
or into
date and a lower
deoxidizer
target.
for steel making.
This gap shows a
but
clear
each
policy
cycle of
choice.
remelting tends to
Our standards trail
concentrate
the USA and
impurities
EU,
rather than dilute
for
them.
efficiency.
The industry term for this is alloy drift, and it is one of the central, unresolved problems of automotive aluminum recycling. The second complication is residual contamination. An engine block at the end of its service life is not a clean piece of metal. Its internal galleries hold a film of motor oil that has, over
Kia's
the
investment in
engine's
EV
working
research and development, made
accumulated
years before the
combustion
market was
byproducts,
ready, now
rare
arrives at its
particles
moment
from
of
bearings
return.
and piston
The path
rings,
forward is a
traces
calculated
of
trade,
sulfur from
positioning the
fuel,
brand for the future.
and in some cases, depending on the vehicle and the duty cycle, measurable concentrations of polycyclic aromatic hydrocarbons. The cooling jackets contain residual ethylene glycol or propylene glycol, often mixed with corrosion inhibitors based on phosphate, silicate, or organic acid chemistry. Cylinder walls may carry deposits of lead from older fuel formulations, particularly in engines that operated in regions where leaded gasoline persisted longer than in North America or Western Europe. None of these contaminants are present in catastrophic quantities in any single block. The problem is one of aggregation. When tens of millions of blocks are stored, transported, or processed without proper containment, the cumulative load of hydrocarbons and heavy metals leaching
price
into
reduction is a
soil and
calculated
groundwater
trade for
becomes
market
a
position
measurable
gain. We
environmental
acquire
burden.
customers, earn
This
credits,
is
and
where the
reinforce our brand.
2026
This
picture
positions us
begins to
competitively.
diverge from earlier years.
The promotion is
In
over, but
several
these 2026
jurisdictions,
models
including
still offer
parts of
great
the
value.
European Union,
Good to know.
California,
I'm
and the
interested in the
Canadian
EV5.
province of Quebec,
Excellent choice. Let's look at the specs.
regulatory bodies have begun reclassifying certain end-of-life engine components as conditionally hazardous waste, requiring that they be drained, cleaned, and stored under cover before being transferred to a licensed recycler. The shift has been gradual and uneven, and enforcement has lagged behind the regulation, but it has produced a visible effect on the ground. Independent dismantlers who once accepted engine blocks as a matter of routine and resold them through informal
The intake records show
networks
20 units,
are
but this containment
increasingly
area is
refusing to handle
overcapacity.
them.
We had a surge. We're
Scrap
reallocating
yards,
to compliance
faced
zones.
with thinner
Photographing
margins
it, please
on
document this for the
contaminated
report. Noted.
and
We'll check the
rising
other zones.
disposal costs for the ancillary fluids have begun to charge intake fees rather than pay for blocks by weight. The result is an inversion of the traditional economics of the scrap engine. What was once an asset has become, in many places, a liability. The downstream consequences of this inversion are already visible in the patterns of informal disposal. Across rural areas in the American Midwest, the Canadian prairies, and parts of Australia, environmental
Mr. Chairman, members of
inspectors
the panel,
have
thank you.
documented a
Our
marked
review shows that
increase
while
in the
most
number
standards
of
are met,
engine blocks
enhancements are needed
abandoned
in data
ditches,
protocols. Thank you.
on the
Certainly.
edges of
The binders
agricultural
detail issues in
fields,
section
and in the
4.2.
back, lots of properties whose owners have either died or moved on. In one survey conducted by a watershed protection group in southern Ontario in late 2025, nearly 400 discarded blocks were cataloged within a single county over an 18-month period, with the majority showing evidence of having been dumped rather than stored. The cost of proper disposal in that region had risen to between $60 and $90 per unit. The cost of driving to a remote location and rolling the block off a tailgate was zero. The arithmetic for a certain kind of operator was straightforward. The environmental implications of these abandonments are not trivial, though they are easy to underestimate. A single engine block weathering in an open field will release its
new models are
residual
exceeding
oil and
projections.
coolant into the
Excellent.
surrounding
And
soil
supply chain updates?
over a period of
Stable
several
with minor
years.
adjustments for Q4.
The oil
Good.
fraction,
We'll review at tomorrow's
depending
meeting.
on its age and composition, may contain detectable levels of zinc dialkylethiophosphate, a common anti-wear additive, along with the aforementioned polycyclic aromatic hydrocarbons. The coolant fraction, if based on ethylene glycol, is acutely toxic to mammals and aquatic organisms in concentrations as low as a few parts per thousand, though it does biodegrade within weeks under normal soil conditions. The metallic fraction, particularly in cast iron blocks, will contribute iron oxide and small quantities of manganese and chromium to the surrounding soil as the block corrodes. None of this constitutes an acute environmental disaster in the sense that a fuel spill or a chemical release would. The harm is diffuse, cumulative, and difficult to attribute to any single source, which is precisely why it has been allowed to persist. To understand why the recycling system has not adapted more
update the online
quickly,
listing.
it is worth examining the economics of the
See
metals
this here?
themselves.
The head gasket's gone.
Cast iron from
We'll need to
engine
pull the
blocks,
engine.
when properly processed,
Just like your grandpa
sells
taught me.
into the steel scrap
Got
market
it.
at a
I'll grab the
discount to
tools.
clean structural steel because of its high carbon content, which complicates the chemistry of electric arc furnaces optimized for low carbon output. The discount has widened in recent years as more steel makers have shifted toward producing high-strength, low-alloy grades that are particularly sensitive to incoming scrap chemistry. Aluminum alloy from engine blocks faces a parallel problem. The global market for secondary aluminum has been reshaped by the rapid expansion of electric vehicle production, which
This
demands
passage in the
aluminum sheet
contamination
and
report
extrusion
raises a red
alloys
flag.
with tightly controlled
Agreed, the
composition.
levels exceed the threshold.
Engine block
The breakwater
aluminum,
proposal needs to
with its
address
high
this.
silicon
Let's review
content,
the modeling
is
data.
poorly suited to these applications. It tends to flow instead into a shrinking pool of secondary casting markets, many of which are themselves dependent on internal combustion engine production that is now in decline. The result is a structural mismatch between supply and demand. The volume of end-of-life engine blocks entering the waste stream is increasing as older vehicles are retired in larger numbers, while the markets that historically absorbed the recycled metal are
First measurement,
contracting or becoming
length
more selective.
245.67 millimeters.
In conventional
Recorded.
recycling
Next.
logic,
Width
this should be a
156.34
temporary problem,
millimeters.
eventually
Got it. One
resolved
more.
by price signals that incentivize new processing capacity or new applications for the recovered material. But the transition timeline of the automotive industry complicates that adjustment. Investors are reluctant to commit capital to processing infrastructure for a feedstock whose long-term volume is, by design, declining. The material is plentiful now and will be plentiful for perhaps another 15 to 20 years, but no one wants to build a 30-year facility to handle a 20-year problem. Several engineering responses have emerged, though none has yet achieved the scale necessary to resolve the issue. One approach, developed primarily in Germany and Japan, involves the segregated melting of engine block aluminum in dedicated furnaces, with the output directed specifically into deoxidizer pellets for steelmaking. This avoids the alloy drift problem by accepting that the aluminum will be consumed in a single, irreversible application, rather than recycled into another casting. The economics are marginal but functional, and the environmental footprint is reasonable provided that the source material is properly cleaned before melting. A second approach, currently being piloted in 3 facilities in North America, applies a thermal treatment process.
These pads
that
are from the old factory.
volatilizes
They need
residual
remediation before we can
hydrocarbons
build.
from the block
I see. What
before it
about soil
enters the
contamination?
shredder,
We'll test that. This rail spur is a
capturing the
major plus for
resulting gas
logistics.
stream for
Excellent.
use
Let's check
as
the boundary.
supplementary fuel within the
The
plant
capital cost
itself.
projections seem
The
high.
process
Agreed,
adds
but the real
cost, but
concern is the
addresses
declining feedstock.
contamination question
Exactly. This
directly
curve could make the
and
project
produces a
unviable.
cleaner
Let's
scrap
scrutinize the
output
supply
that
chain
commands a
assumptions.
higher price in the metals market. A third approach, more speculative but worth noting, involves the direct repurposing of intact engine blocks as structural elements in civil engineering applications. Researchers at 2 European technical universities have published preliminary studies on the use of cast iron engine blocks as
The intake
ballast
yard at the
in
end of the
marine
day, overwhelmed
breakwaters,
by an
where
unusually
their
large
density,
accumulation of scrap
irregular
engine blocks.
shape,
Piles
and
fill the area,
resistance
stacked
to
on pallets where
corrosion in
possible, with
salt
the rest on
water
bare ground,
make
far beyond
them
normal
functionally
capacity.
comparable to the quarried stone traditionally used for the purpose. The proposal has met with skepticism from environmental regulators concerned about residual contamination and from cost engineers who note that the labor required to clean, transport, and place the blocks exceeds the savings on stone. It is unlikely to become a mainstream solution, but it illustrates the kind of lateral thinking that the problem may eventually demand as the conventional recycling pathway becomes increasingly strained. There is also a human dimension to this transition that tends to be obscured by the focus on materials and markets. The automotive recycling industry employs, by various estimates, somewhere between 200,000 and 300,000 people in North America alone, distributed across a network of dismantlers, scrap processors, parts resellers, and specialty recyclers. Many of these operations are family-owned, multi-generational businesses built around assumptions about the value of automotive scrap that are now being revised in real time. The shift in the economics of engine block disposal is not merely an environmental story or a metallurgical one. It is also a story about a workforce that is being asked to absorb the costs of a transition it did not design and cannot easily escape. When a small dismantler in rural Pennsylvania finds that the engine blocks accumulating behind his shop have shifted from a source of supplementary income to a source of disposal liability, the response is not always to invest in compliant infrastructure. It is sometimes to close the shop or to look the other way when an unmarked truck arrives at night. What emerges when these threads are followed to their ends is a picture that is more nuanced than the framing suggested by the simple question of environmental impact. The discarding of old gas engine blocks in 2026 is not a hidden catastrophe. in the sense of a single dramatic harm being concealed from public view. It is rather a slowly unfolding consequence of a transition whose costs have been allocated unevenly across the industrial landscape. Automakers who designed and profited from the engines bear relatively little of the disposal burden. Recyclers, operating on thin margins, are absorbing more of it. Local environments, particularly in jurisdictions with limited enforcement capacity, are absorbing the rest. The cast iron and aluminum that once circulated through a functional, if imperfect, industrial loop is increasingly accumulating at the edges of that loop, in storage yards, in agricultural ditches,
Okay, marking the
in the
position.
unbuilt corners of
Got it.
properties whose
Photographing now.
owners do not know what else to do
Dimensions
with
look
it.
right. Check the
The likely
GPS.
path forward,
Coordinates are
insofar
set.
as
We're
one
good.
can be discerned from the current trajectory, involves a combination of regulatory pressure, processing innovation, and a gradual rationalization of the recycling infrastructure to match the new realities of feedstock supply. Extended producer responsibility frameworks, already in place for batteries, tires, and electronics in much of Europe, are beginning to be considered for engine components, though the political resistance from automakers has been substantial. Public investment in dedicated processing facilities, modeled loosely on the lithium-ion battery recycling plants now being built in several countries, has been
That'll
proposed
be
but rarely
$25.
funded.
Here
The
you
most
go.
realistic
Thanks.
near-term
That's for the engine
outcome is
block.
probably a
Got
slow
it.
tightening of disposal
I'll mark it
standards,
down.
an
Appreciate
attendant
it.
rise in the cost of legitimate
What about this
recycling,
engine block?
and a corresponding
that's not for
increase
sale.
in the volume of
You sure?
material
I'd pay a
that
fair
escapes
price.
the system through
I appreciate
informal
it, but
channels
no.
until enforcement catches up. For the casual observer walking past those uneven rows of engine blocks behind an independent automotive shop, none of this is visible. The blocks look as they have always looked. They are heavy, dirty, and apparently inert, the residue of a technology whose departure has been announced for so long that its actual departure has begun to feel anticlimactic. But the inertness is a kind of optical illusion. The blocks are not waiting passively to be recycled. They are participants in a quiet rebalancing of industrial economics, and the question of what becomes of them in 2026 and the years immediately following is not a marginal question about scrap metal. It is a question about how the costs of industrial transitions are distributed when the transitions themselves are real but incomplete. The internal combustion engine has been, by almost any measure, one of the defining technologies of the modern world. Its retirement, when it finally occurs in full, will not be a single event. It will be a long sequence of smaller events, of which the disposal of a few 100 million engine blocks is one of the more mundane and one of the more revealing. The story is not finished, and it will not be finished quickly. But it is being written slowly, in the rust streaks running down the sides of cast iron blocks stacked on wooden pallets in shops and yards and quiet fields across the geography of an industry that is learning, against its preferences, what it actually costs to put something down,